Learning objective 4 is limited resources. In this case, we have constraints on one or more resources, and what do? How do we make the most money? Capacity might be limited. In the example of the 1,000 units of chairs, that was a constraint. Or it could be labor hours because you have limited amount of skilled labor. Or materials might be constrained. You only have so much raw material that you can get from your vendor, so you have to make the best you can with it. Or machine hours. You have a limited amount of machine hours and you have to then deploy it toward the most profitable products for the machines. So these are just 4 of many examples of limited resources that have to be factored in making a decision. Let's do an example. Here we have Wilson Sports, and they make baseball bats, and they use a specific type of wood called white ash. And due to the weather problems, the wood supply this year is constrained. They can only get 24,000 board feet of white ash. And so the question is, what should they do with the wood? Which bat should they make? They have 2 models. One is a deluxe and the other is a basic. The information is provided here. The selling price for the deluxe is $75 a bat. For basic is $54. The unit variable costs are $34 for deluxe and $25 for basic. So the unit contribution margin for deluxe is 41 and the basic bat is 29. And the number of board feet required to make a bat is 3.4 for deluxe and 2.2 for the basic. The question is, which do you make? On the outset, you'd say, well, again, no brainer. Deluxe bat's 41, basic bat's 29. Let's make all the deluxe bats. Assume that Wilson needs to produce at least 2,000 of each to remain competitive. They need to be able to provide their customers with both models of bat, at least 2,000. All right, so let's go to Excel. Now we're in Excel. Let's do the analysis. This is a little different from the prior because there is a constraint and we're optimizing. Here we're going to do a slightly different approach. First step is contribute the contribution per board foot to find which is most profitable, not from a unit standpoint, we already know that's the deluxe bat, but on a per unit of constrained resource, in this case wood. What is the profit for the deluxe? 41. What is the number of board feet used? Divided by 3.4. This represents, so this is dollars per board foot. And this is for the deluxe, and this is for basic. For basic, it is $29 divided by 2.2. So it's 13. So we see that we're better off making the basic bat. Even though it's tempting to make the deluxe, we make more money, $13 versus $12 for the deluxe. So let's use the wood first to meet our minimum required for the least profitable product, because we're going to go as little as we can for the one that we have to make. We'd actually prefer not to, but our constraint is we must make both. What is the units of the lower profitability? 2,000. What is the usage of wood? In this case, the deluxe is the lower profitability, 3.4. So how much wood do we need to use up for that bat? 2,000 times 3.4, 6,800. So how much wood is left? The allocation to deluxe bat, which is our minimum, is 68. And the available for the more productive bat is the 24,000 minus the amount that we used up on the deluxe bat. We could use 17,000.2 for the basic bat, which makes us more money. And just check the math. If we add those two, it's the 24,000 board feet. All right, step 4. How many bats do we make of the second product? The first bat, just to remind ourselves, we have 2,000. So the basic bat, which is the better bat we want to make, is based on the board feet of 17,200. And the board foot per bat is equal to 2.2. So the number of basic bats we're going to make is 17.2 divided by 2.2 is 7818. So the summary, the number of bats, 2,000 and 7818, and that's our highest profitability. So that's it for limited resource. All right, so let's look at theory constraints. It states that each process has a bottleneck, and that bottleneck constrains your flow. And so production cannot take place any faster until you address that bottleneck. So we maximize this in a constrained environment by discovering what are these constraints, and we can quantify what is the difference if we were able to address it as opposed to being constrained by that. So we want to find the constraints, address it, move on to the next constraint appears, address that. What is our role? We should identify them. We should schedule production to use the capacity we do have, and then avoid buildups of inventory, which are very wasteful in terms of material and capital. And then, of course, as stated, get rid of that bottleneck. Summarizing Mod 17, relevant costs. Relevant costs are those that are in the future and they differ among alternatives. Some examples of things to watch out for are sunk costs. Do not count them. They're irrelevant. Opportunity costs, do count them. They are relevant. And disposal value of a replaced asset, which are relevant. Number 2, we looked at the decision making using relevant costs as a consideration. Learning objective 3, we did scenarios. We did 4 of them. We did changing business plans, adopting or not a special order, outsourcing, which is make or buy, and selling or processing further. Finally, we looked at learning objective 4 is in constraints. If we have constraints, then how do we work around that constraint such that we can then maximize our profit? Finally, we looked at a more generalized view, which is the theory of constraints, which provides for us to find a constraint, schedule to consider it, and then in the meantime, try to get rid of the constraint. So that's it for session number 7, and I will see you in class.